handout you've just been given is part of the data sheet you're going to get in the exam. So in the exam that's coming up in January, you will get a question on Laplace transforms. So here are the transforms that will be in there. Two sections to it. Notice the bottom one is what we've been focusing on particularly up to now. If I've got some components like a resistor or an inductor or a capacitor in a circuit, then these will be the values we give them if we put them into a problem involving this S space. We transform them using a Laplace transform, in other words. The top one is giving us, first of all, what some inputs might be, step or ramp, what they would be in what they transform into, and then the bottom ones, the exponential decay, the sine, cosine, damped sine and cosine waves, are the sorts of transforms we might end up with that we then will be able to say, well, if I have a transform like that one, for example, it will be this sort of output. And if you look at that, hopefully you could sort of sketch what that might look like. Sine wave, so you can imagine a sine wave, but this bit in front, e to the minus alpha t, is an exponentially decaying amplitude. So we've got a damped sine wave. That's where that comes from. So it's all about these Laplace transforms. It's all about being able to predict what our output will be over the initial time period before it settles down into its steady state, the transient period, in other words, transient period, by seeing what we end up with as a transform and then identifying which function that corresponds to. And that's what we're going to look at a bit more today. We're going to look at some circuits involving components, resistors, inductors and capacitors, and then put a supply voltage across them and see what sort of output we're going to get.